everybody, Harold here. I want to continue my series on data visualization. I want to go through a few more packages that I use. So let's get started. So we need to install a few packages. So library tidyverse. So then we need to run library tidyverse for using the pipe, etc., and dplyr gt extras to make some nice looking tables. And then the 5 packages I'm going to run through: skimr, janitor, ggally, psych, VIM. Once you've got those loaded and ready to go, we'll start with skimr, and it's just a quick visualization. So I'll show you the data first. This is air quality table from the tidyverse. Air quality data set from the tidyverse. Ozone, solar R, wind, temp, month and day. Nothing special. Do you have some NAs? So if I want to skim air quality, that gives me a nice summary. So the name, number of rows and columns, column type, frequency, numeric 6. So the most common column type is numeric, and it's 6. Uh, variable type, numeric, 6 of them. 100% complete on these. These have some missings, mean, standard deviation, uh, quartile range, median at 50, and even a small histogram. So that's a nice, quick data summary. 2 other things you can do with this real quick are count the number of missing in the data frame. So in missing air quality, and 44 missings in air quality. Or you could check just one column. So in missing air quality ozone, $ ozone, 37 missing in ozone. So there's 7 missing in solar R. And that's just a real quick way to look at the quality and summary stats on your data set. Janitor, most people use janitor for clean names. There's a really cool thing in janitor called table with a YL, and it also has an adorn argument. So I could say we'll use the iris data set this time. Iris, pipe iris into, we'll do a species table, and we'll pipe that in, and we'll adorn it with totals for each species and adorn it with percentage formatting. So really quick, I get a small table, count of species, percent of the database that species is, total line. You know, so adorn has done the totals and the percent formatting. That's pretty cool. Here's another one I like to do, ggally. In order to do this, I'm going to use the mtcars database from the tidyverse, and I'm going to convert the cylinder column to a factor. At that point, I can now say gg pairs for mtcars. Choose the columns I want. Color by the number of cylinders is a factor. Show the correlation coefficients in the upper panels with the upper equals list continuous wrap core size equals 5. Add a smooth line to the plot with a lower list continuous smooth. And show the bar plots on the diagonal. The diag list continuous wrap bar diag bin width 2. So that's GG pairs and a bunch of arguments. You can go look in ggally documentation, see how these work. I'm going to show you. It creates it, it's creating, and bam. Okay, we've got MPG horsepower, weight, cubic on the X and Y axes, correlations between each, color by 4, 6, and 8 cylinders, histograms showing what percentage by color, and scatter plots for each one with smooth lines. So that's a really cool, quick way to get a visual view of the correlations, frequency, and distribution of your data. Next one is psych. So psych, the main function in there is describe, and you just say describe iris. And I put GT theme Guardian. I pipe that in to make a nice looking table with the Guardian style from GT Extras. So there we have variables 1, 2, 3, 4, 5, number 150, the mean, the standard deviation, the median, trim median, average deviation, minimum, max, range, skewness, and kurtosis. Skewness and kurtosis, if your histogram is taller on the left, it's skewed left. Kurtosis, if you have normal tails, it's -2, and it varies from that. So it's how it spreads out on the tails, and the standard error of the estimate. Harris panel iris gives me a histogram with a line for each combination, a correlation of each combination, scatter plot, and density plots for each, a scatter density plot for each combination. So that's really cool. You can tell I like this stuff. Lower core iris is just a simple lower correlation. It just doesn't do the mirror part. See down here, it's just the bottom and the right, not the top. Bottom and the left, not the top and the right, which is just a mirror. Um, Now, core plot. But here I've done select the numeric columns, get the correlation matrix, and then plot it. The title, colors, number of color breaks, legend, and display only the lower triangle. Hide the diagonal elements because they're ones, and the upper triangle is a mirror. So these are the correlations for sepal length, sepal width, pedal width, and pedal length. Pedal width and pedal length. So that's psych. Now, I mean, my favorite one of these is kind of VIM because VIM lets you go onward. It's got some visualizations, but its main purpose is for imputation. So what you can do here is library VIM, I've got all that done. If you say agra msleep, we use the msleep database from the tidyverse, numbers equals true, you get this really cool combination proportion of missing plot for the NAs in the msleep database. So it shows you, for instance, brain weight, where they're missing, how many are missing, and proportionally over here in this graph. Two other things you can do are bar miss, and that shows you bars for all the observations and what's missing in ozone. And his miss is a histogram of missing values. But the real power of them is showing your imputed values. So let me create just a quick data frame here. First column ID 1 to 20, second column numbers with a bunch of NA sprinkled in. So stuff. Let's show you stuff real quick. So there we go, 2-column data frame, ID and numbers. Now, if I wanted to, and I'm going to do, my next series is going to be on imputation. Imputation is replacing your NAs with something approximate to what should be there, or a calculation, or whatever you want, using some statistical method, or just put 0 in there to fill out your data frame and use it for analysis. So I want to replace the impute. I want to impute the missing values and stuff using the KNN method, which is part of the VIM package. KNN looks for the K nearest neighbor, the nearest neighbor to that row that has similar values to the values in the columns that are there. So if I had 3 columns and one of them was NA, it would find the similar row with the first 2 columns, get the median of that. So I choose 5, which is the default. It's going to take the 5 most similar rows that have the value that's missing and take their median. So I'm going to say stuff 2 is K nearest neighbor stuff. I'm going to show you stuff 2. Notice all the NAs that will say 16 through 20 on stuff. Now it's imputed them all to be 52s and includes an ID imputation column, which it didn't do anything, and they're all false, and a numbers imputation column that did show stuff that was changed. So true, 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 where it was changed. So the great thing about that is now you can use VIM to view the imputed columns. So when I did ag stuff numbers equals true, okay, all that red. Now I do ag stuff 2 delimiter equals imp, and all the yellow is what changed. So that's now plotting the imputed value column. This is great stuff. Now you can see what changed when you imputed. You want to see the end result of the imputation is, well, we'll just say aggregate. Say stuff 2, and we'll go back to numbers equals true. And now it's all blue because we changed it. So red with the missing, we imputed it. Yellow, the imputed data frame, nothing's missing. So that's VIM. So those are a few packages I use all the time. You can look more into them on your own. I'm going to start doing an imputation series. I'm going to do zoo NAs, VIM here, and a package called mice. I hope you liked this one. If you did, please like and subscribe, and I'll see you next time. Thanks, everybody.